Let's ask our AI a question. Explain to me AI in 4 sentences. Cool, so it's generating back a coherent response that is very understandable. And in today's video, I can show you guys how to create a similar interface completely locally using Hugging Face with Streamlit and Transformers. Okay, so now we need to start with the setup of the environment. So the first thing we want to do is create a Python virtual environment. We'll just call this maybe ChatGPT clone for now. And once this is created, then we can activate it. So we cd into ChatGPT clone, and then go into bin, and then we activate. Okay, so now we have a couple libraries to install. We're going to install Transformers, the Hugging Face API for LLM inference, and we're going to install PyTorch and Streamlit. PyTorch obviously being the LLM backend and the module that also loads the model onto the CPU and RAM, and then Streamlit, which is going to be our main front-end UI. So we're going to pip3 install Transformers, Torch, and Streamlit. Okay, so before we start coding, we actually need to install one more library, and that is Accelerate. This is going to help us with the faster processing of LLMs with PyTorch. It works hand in hand with PyTorch, so PyTorch naturally becomes dependent on that over time, and now it is a dependency in later versions. So we're going to have to install that. So now let's create a new text file. We'll save this as main.py in our base code folder, and then inside code we're going to create a new folder called output, and inside output we want to create a new file called generate output.py, and this is going to be our backend. And we want to create the backend first so we know that everything on the base level works before we move on to the UI. So let's go ahead and import our modules. We're going to import Torch, which is going to be the module that loads the model onto the CPU or GPU, depending on if you have one or not. So now we're going to say from threading thread. This will basically help the LLM output text in a stream instead of one whole giant blob every 30 seconds. So that is what that is for. And then Transformers. This Transformers module by Hugging Face helps us pull the model from the Hugging Face hub and downloads it to our local device. So from Transformers, import auto tokenizer, and then auto model for console. Notice the spelling there. It's not casual, it's causal. C-A-U-S-A-L. And then text iterator streamer. Cool. So now you can go ahead and open up your browser and head to Hugging Face. For this tutorial, we're going to use the Technology Innovation Institute Falcon 3B Instruct model. I found this to be a very reliable model. It works on basically all devices, including edge devices like Raspberry Pis, and I think it's a great model overall, so we're going to use this one. We're going to paste the model in there, and we'll set our tokenizer equal to auto tokenizer dot from trained model. Then now we can set another model parameter, in lowercase this time, equal to auto model for console LM. In this, we're going to pass model torch dtype equals torch bfloat 16. So this is going to be a pretty high accuracy type of model if we load it in this format. And then device map equals auto. And what this does basically here, this last line, is it scans the device for available components to load the model onto. So if you have a GPU with enough VRAM, it'll attempt to load the model on that. If you have a CPU instead, it'll load the model onto that. So you don't exactly have to specify. It's just a cool feature of PyTorch. And then we're going to create our generate output function. This is where all the logic happens. We're going to pass the messages parameter. Then we're going to set our inputs equal to tokenizer dot apply chat templates. And then we're going to inputs messages, and then add generation prompt is true. We're going to tokenize to a model readable format our inputs, and then we're going to return tensors into PT format, and then we're going to return dictionary to be true. And last but not least, go ahead and delete the space here, and then we're going to load the model to our device, which is the CPU. And now we can specify our streamer equal to text iterator streamer. So this will basically help the model generate in a stream and not in just one giant blob, as I said before. So now we can put through our tokenizer skip prompt is true, and then skip special tokens is also equal to true. Basically what skip special tokens does is when a model is trained on a dataset, it'll often be trained to respond something like this. So this is the first token that it will generate, so that the rest of the time the model goes, it knows that this is its response. And typically these tokens get in the way. It just makes the model's response very unreadable. So that is what skip special tokens does, is it deletes those before and after tokens. So enough with my rambling there. And we can set our generation arguments. So generation kwargs is equal to dictionary. We're going to pass through our inputs. Streamer, it's going to be equal to streamer, and then max new tokens equals, we're going to set it to 512 for now, just so the model doesn't ramble the whole time. We're going to set our temperature to 0.7. Now, if you don't know what temperature does in AI inference, is it basically regulates, how precise or how inaccurate you want the model to respond. So, or I guess a better way to say that is like how understandable you want the model to respond versus how short the model you want to respond. It's a whole bunch of things. The best temperature to set your model to if you want it to act normal is 0.7. So as an example, if I set the model temperature to 0, it could, spit out like thousands of tokens and make like not a whole lot of sense. And we tune that to basically, we tune the temperature variable so that it does not do that, is what I'm trying to get at. And then after temperature, we're going to set our do sample to be true. Okay. So now we are done with setting the arguments for generation. Now we can start the threading process. So thread equals thread module target equals model.generate, and then kwargs equals generation kwargs, like that, and then start the process on the CPU. Now we're going to set our response to be blank for now, and then for new text in streamer, response plus equals new text, and then we're going to yield response, and then we're going to pass thread.join. Basically, what this last chunk of code here does is every time a new token is generated, it then adds that token, decodes it, and puts it in a readable format so that it looks like a stream of text going through. So now we can save this file with Control-S, and then now we can head to the terminal and create main.py. As you may have seen, I already pre-created it, or maybe I created it earlier. I don't know. I'm tired right now. But anyways, we can go ahead and start with the front-end UI stuff. So import Streamlit as st, and then we're going to import our backend module from output.generate output, and then we're going to import the generate outputs function. And we're going to set our page title as set page big, page title equals local LLM chat, like that. And then we're going to set the other page title, but for the actual UI, as the same thing. And then we're going to say if messages not in st.session state, then we're going to pass st.session state messages is an empty list for now. And so now basically what we're going to write is if we want to start up the local AI app another time, we're going to load the previous messages from the previous time that we were chatting into the UI. So for message in st.session state.messages, we're going to put with st.chat message, and then the parameters are going to be message and role. And st.markdown the message content. Okay, now we're going to specify the user prompts. So if prompt equals st.chat input, just going to say type or message. Then we're going to add this message to the session state of Streamlit. So st.session state messages append, and then in brackets, we're going to put the role. It's going to be user, and then content is going to be the user input, aka the prompt. Prompt should not be in quotations. And now we can say with st.chat message, that's the role of the user. We can say st.markdown message or prompt. So basically, when the user clicks enter or send, then that's going to display the message at the top of the screen as a chat, kind of like a ChatGPT style site. And then with st.chat message, let's see, role of the assistant this time, we can say placeholder equals st.empty, and then full response, it's going to be an empty string for now, and then for partial response and generates outputs st.session state messages, and we're going to say full response, it's partial response, and then placeholder markdown full response plus just the empty string for now. Or maybe we put like that in there just to show the model is thinking. And then after that, placeholder markdown full response. Okay, so now we can go ahead and backspace a little bit more, and then st.session state messages.append role, excuse me, in quotation marks, the role is the assistant, and then the content is going to be the assistant's response. Okay, so now we can go ahead and save this, and we can run the code now. So let's ls, just to make sure everything is there. So, cool. Now we can run Streamlit, run main.py. And no module named Torch Vision. Okay, that's fine. So what we can just do is we can Control-Z out of there, and then we can run pip install Torch Vision. Not a super hefty library. And then we can run this again now. OS error. Auto model for causal LM. For causal LM is designed to be instantiated using the auto model for causal LM from pre-trained model name or path. Okay, so it looks like the error here is in generate output here. auto tokenizer. Ah, I see. Yeah, so we need to add the from retrained argument there. Save this, and then rerun. Full response is not defined. Okay. My guess is that this is just a you know, a placement error here on the code block. I think I might see why. So right here it looks like main.py. Yes, that is exactly it. Sorry, I was just thinking out loud for a second. Just have to indent this a little bit, and then Control S. I believe that is the fix. Cool. So we successfully debugged that. Okay, so let's ask the model. Hey, how are you doing? On the back end here, it's throwing an error. I'm not entirely sure what this is. If this error was it's given us trouble again here. So let's see what this error is here. So let's go to generate output, and the error it's giving us is that list attribute has no attribute to shape. Okay, so I think I found the error here after taking a closer look at it. Under generate output.py, under the where is it? I lost my place. Under the generate output function, instead of returns tensors, it is supposed to be return tensors without the S. So just a simple typo there. We'll see if this works. Let's run Streamlit again. Cool, everything loads correctly. So now let's give the model a simple command, write a hello world script Python. Great, so now this is working. So what you can do with this, if you would like, is expand the functionality of this app to include other models. Save, certain settings, such as the temperature of the generation. And we might do that in a later video. And yeah, thank you guys so much for watching. Please like, subscribe, and share with your programmer friends if you would like. And this has been building a ChatGPT clone on Tech with Peter. Have a good one, guys. See you in the next one.